To solve question number 8 of SSB lecture on mathematics exam 2023. In this problem, question say for what value of lambda belongs to Z3, the quotient ring Z3x quotient ideal generated by SQ plus S square plus lambda is a field. So remember one thing, the quotient ring Fx quotient ideal generated by Px is field. Here Px is a polynomial is field if and only Px is irreducible in Fx. Okay, of course F is field here. Now in this problem F is given Z3 and we know Zn is a field if and only if n equal to prime. So here n equal to 3, so Z3 is a field. So now we can say Z3x quotient ideal generated by the polynomial SQ plus S square plus lambda is field if and only if the polynomial Px, that is S cube plus S square plus lambda, is irreducible over Z3. So now how we can check a polynomial is irreducible over a field or not? So how you can say, here we see Px is a polynomial of a degree 3. So now we can apply root test. So root test, when we apply, when the polynomial is of degree either 2 or 3, then we can apply root test here. So my root test say Px belongs to Fx is irreducible over F if and only if Px has no zeros in F. Okay, so this is only happen if Px, remember one thing also here, then this is only happen when Px either of degree 2 or 3. So here degree of Px is 3, so now we can apply here. Okay, so now Px is given, Px equal to S cube plus S square plus lambda. So you have to check for lambda equal to 3, 0, 1, 2, which condition, for what value of lambda Px is irreducible in Z3. So now for lambda, if I take lambda equal to 0, Px becomes S cube plus S square, and if I find the value of Px at x equal to 0, then I get 0 q, that is 0, plus 0, that is 0. So here I get 0 is a 0 of Px. So for lambda equal to 0, Px is not a irreducible. So now for lambda equal to 1, Px is, for lambda equal to 1, Px is S cube plus S square plus 1, and if I find the value of P of 0, then that is 1, that is non-zero. Okay, now if I find the value of Px for x equal to 1, then I get 1q plus 1 square, that is 1, plus 1, that is 3, and 3 is isomorphic to, 3 is congruent to 0 modulo 3. Okay, so here I get 1 is a 0 of Px. Okay, so this is for lambda equal to 0, Px is also not irreducible. So for lambda equal to 1, this condition also fail. So for lambda equal to 2, Px equal to S cube plus S square plus 2, and if I find the value of Px at x equal to 0, then I get 2, that is not congruent, that is not equal to 0. And if I find the value of Px at x equal to 1, that is 1q, that is 1 plus 1 square, that is 1 plus 2, and that is equal to 4, and 4 is congruent to 1 modulo 3. Okay, so 1 is, this is not equal to 0 also. And if I find the value of P of 2, that is 2q, that is 8 plus 4 plus 2, that is 8 plus 4, that is 12 plus 2, that is 14. 14 is congruent to 2 modulo 3. Okay, so if here I get for every value of z3, for every value of z3, p of x has no zeros, has no zeros in z3. So here I say therefore px is irreducible for lambda equal to 2. So here I can say z3x quotient ideal generated by sq plus square plus lambda is filled if and only if lambda equal to 2. So here option B is true. Thank you.